Hello students, how are you? Okay, let's start the chapter Laws of Motion. In this chapter, first of all, you should know what is force. It may be defined as an agency, a push or pull, which changes or tends to change the state of rest in the direction of motion of a body. Force is a vector quantity. Then, what is inertia? It is the inherent property of a material body. By virtue of it, it cannot change by itself. Its state of rest or uniform motion in a straight line. Inertia is of three types: inertia of rest, inertia of motion, and inertia of direction. Mass is a measure of inertia. If a body has more mass, it has more inertia, meaning that it is more difficult to change its state of rest or of uniform motion. Momentum. What is momentum? It is the quantity of motion in a body. It is equal to the product of mass m and velocity v of the body. Momentum p equal to mv. Momentum is a vector quantity having the direction of velocity v. Now I am going to explain you Newton's first law of motion. This is also called law of inertia. It states that every body continues in its state of rest or of uniform motion along a straight line unless an external force is applied to change that state. This law defines force. Newton's second law of motion. What is Newton's second law of motion? It states that the rate of change of momentum of a body is directly proportional to the applied force, and the change in momentum takes place in the direction of applied force. This law gives a measure of the force. Mathematically, F equal to dp upon dt. It, it can be written as d upon dt mv. P means mv. Then m is constant, m dv upon dt. dv upon dt is equal to a. It is called acceleration. Then m a. When m is constant and v changes, then f equal to m dv upon dt. When v is constant and m changes, then f equal to v dm upon dt. In component form, Newton's second law of motion can be expressed as fx equal to dpx upon dt, fy equal to dpy upon dt, fz equal to dpz upon dt. Now, Newton's third law of motion. It states that to every action, there is an equal and opposite reaction. Mathematically, FBA equal to minus FAB. Forces of action and reaction never cancel out because they act on different bodies. Forces of action and reaction never cancel out because they act on different bodies. Impulse of a force. Now I am going to explain you impulse of a force. Impulse is the total effect of a large force which acts for a short time to produce a finite change in momentum. It is defined as the product of the forces and the time for which it acts and equal to the total change in momentum. Impulse equal to force into time duration. Apparent weight of a body in a lift. Apparent weight of a body in a lift. First is when a lift moves upward. When a lift moves upward with uniform acceleration, the apparent weight of a body in the lift increases. If R is the reaction force, then R minus mg equal to ma. Second is when a lift moves downwards, with acceleration a, the apparent weight of a body in the lift decreases. Then mg minus r equal to ma. Third is when a lift is at rest or moves with uniform velocity, a is 0, means a is 0, acceleration is 0. The apparent weight of a body is equal to its true weight, r equal to mg. When the lift is at rest or moves with uniform velocity, there is no change in the velocity, then the reaction force will be equal to mg. Fourth is when a lift falls freely, a equal to g, the apparent weight of a body in the lift becomes 0. R equal to mg minus g means 0. Now, law of conservation of linear momentum is in the absence of any external force, vector sum of the linear moments of a system of particles remains constant. Second is when two bodies collide, total momentum before the collision equal to total momentum after the collision. M1 U1 plus M2 U2 equal to M1 V1 plus M2 V2. Third is when a bullet of mass m is fired with a velocity v. When a bullet of mass m is fired with velocity v from a gun of mass capital M, the gun recoils with velocity v. Then momentum of gun equal to momentum of the bullet. mv, capital M capital V equal to minus m small v. Recoil velocity of the gun v equal to capital V equal to minus mv upon capital M. Rocket propulsion. In which principle rocket propulsion occur? It is an example of momentum conservation, in which the large backward momentum of the ejected gases imparts an equal forward momentum of the rocket. Due to the decrease in mass of the rocket fuel system, the acceleration of the rocket keeps on increasing. Let u equal to velocity of the exhaust gases. Then dm upon dt, it is the rate of ejection of fuel. Thrust on rocket, that will be F equal to minus u dm upon dt. Acceleration of rocket A equal to u upon m0 minus t dm upon dt, under the bracket dm upon dt. Velocity of the rocket v equal to v0 plus u log of m0 upon m to the base e. Concurrent forces. What are concurrent forces? The forces acting at the same point of a body are called concurrent forces. If many forces are acting at the same point, that forces are called concurrent forces. Equilibrium of concurrent forces. A number of concurrent forces acting on a body are said to be in equilibrium if their vector sum is 0, or if these forces can be completely represented by the sides of closed polygon taken in the same order, that is vector f1 plus vector f2 plus vector f3 plus dash 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 plus vector fn equal to 0. Now Lame's theorem. What is Lame's theorem? It states that if three forces acting on a particle keep it in equilibrium, then each force is proportional to the sine of the angle between other two forces. If alpha, beta, and gamma are the angles between F1, F2, and M3, F3 and F1, and F1 and F2, then according to Lame's theorem, F1 upon sine alpha equal to F2 upon sine beta equal to F3 upon sine gamma. This is called Lame's theorem. Motion of connected bodies. Motion of connected body. Suppose two bodies of mass capital M and small m. Capital M is greater than small m. And these two bodies are held tight at the ends of inelastic spring, passing over a frictionless pulley. Then acceleration of the masses A equal to capital M minus small m upon capital M plus small m hold under the bracket small g. Tension in the string, that will be T equal to 2 capital M small m upon capital M plus small m into g. Now friction. What is friction? Whenever a body moves or tends to move over the surface of another body, a force comes into play which acts parallel to the surface of contact and opposes the relative motion. This opposing force is called frictional force. I am repeating once again. When a body moves or tends to move over the surface of another body, a force comes into play which acts parallel to the surface of contact and opposes the relative motion. Static force, static friction. The force of friction which comes into play between the two bodies before one body exactly starts moving over the surface of another body is called static friction. Static friction is self-adjusting force. It is self-adjusting force. Limiting friction. The maximum force of static friction which comes into play with a body just starts moving over the surface of another body is called limiting force, limiting friction. Kinetic friction. What is the force of friction which comes into play when a body is in a steady motion over the surface of another body is called kinetic or dynamic friction. Kinetic friction is less than limiting friction. Kinetic friction is less than limiting friction. Now, what are laws of limiting friction? Limiting friction, what are the laws? Number one is the force of limiting friction depends upon the nature of two surfaces in contact and their state of roughness. Number two is the force of limiting friction acts tangentially to the two first surfaces in contact and in direction opposite to that applied force. Third is the force of limiting friction between any two surfaces is independent of the shape or area in contact so as long the normal reaction remains same. Fourth is the force of limiting friction between two given surfaces is directly proportional to the normal reaction between the two surfaces. F is directly proportional to R, or it can be written as F equal to mu R. Mu is called coefficient of limiting friction. Now, coefficient of limiting friction. What is coefficient of limiting friction? It is the ratio of limiting friction to the normal reaction. Mu equal to limiting friction upon normal reaction. Coefficient of kinetic friction. Coefficient of kinetic friction. It is the ratio of kinetic friction to the normal reaction. Kinetic friction upon normal reaction, it is called kinetic friction. Angle of friction. What is angle of friction? It is the angle between the resultant of the limiting friction and the normal reaction makes with the normal reaction. If theta is the angle of friction, then tan theta equal to mu. Mu is the angle of friction. Now I am moving to centripetal force. Centripetal force. What is centripetal force? It is the force required to make a body move along a circular path with a uniform velocity. Once again, I am repeating once again the statement. It is the force required to make a body move along a circular path with a uniform velocity. It always acts along the radius and towards the center of the earth, toward the center of the circular path. The centripetal force required to move a body of mass m along a circular path of radius r with velocity v is given by F equal to mv square upon r. F equal to mv square upon r. This is called centripetal force. Now centrifugal force. What is centrifugal force? It is a frictional force. It is a frictional force acting radially outwards on a particle moving in a circle and is equal in magnitude to the centripetal force. It is always equal to the centrifugal force, and centripetal force both are equal, but the direction is different. Centripetal force acts in the direction of center and centrifugal force acts in the direction of just opposite of the centrifugal force. Banking of roads. Banking of roads. The maximum angle with which a vehicle can negotiate in a circular turn of radius r and banked at an angle theta is given by v equal to rg tan theta. V is the speed of the vehicle. A vehicle taking circular turn on a level road. A vehicle taking circular turn on a level road. If mu is a coefficient of friction, if mu is the coefficient of friction between tires and road, then the maximum velocity with which the vehicle can safely take a circular turn of radius r is given by v equal to mu rg, under root mu rg. Motion in a circle. Consider a body of mass m tied at, at the end of a string and rotating in a vertical circle of radius r. Then v equal to under root u square minus 2gh. Inertial frame of reference. There are two types of frame of reference, inertial frame of reference and non-inertial frame of reference. Now, inertial frame of reference. An inertial frame of reference is one in which Newton's first law of motion holds good. In inertial frame of reference, Newton's first law of motion holds good. Non-inertial frame of reference, what is? A frame of reference which in accelerating with respect to an inertial frame of reference is called non-inertial frame of reference. In a non-inertial frame of reference, the second law of motion, F equal to ma, is not valid. It does not hold good. It takes the form of F minus ma. If you like my video, please like and subscribe my channel. Thank you.